So hello everyone, let us solve today's GfG problem of the day, and the problem name is Kadane's algorithm. So let us read the problem statement. So given an integer array ARR, we need to find the contiguous subarray containing at least one number that has the maximum sum, and we need to return its sum. So this question is actually based on one algorithm which is known as Kadane's algorithm. So we need to implement that algorithm in this question. So let us see this first example and try to understand what the algorithm is and try to dry run that algorithm on this first example. So let us see now. So this is the first example that they have given. Now first of all, the question is, why do we actually need Kadane's algorithm? So why do we need it? Now in this question they are asking us to find the maximum sum subarray. Now if you do it in a brute force way, what will it happen? You will start from 1, you will keep your I pointer here, and then you will check with J pointer with each and every subarray starting from I and ending at J. So there will be one subarray which will be containing only 1. There will be one subarray which will be containing 1, 2. So this J will keep on going for I equal to 0 at 0 index, where I is pointing to this value 1. Then I will move to here, then again J will start from here, it will go to here. So what is happening? You are running two for loops. So for I to n, and then inside it another loop you are running for J equal to I till n. And you are running again one for loop which will be taking the sum from ARR of I till ARR of J. So actually you are running 3 loops. So again let's say there is one K pointer which will be moving from I till J. So you are running 3 for loops, and in worst case this time complexity can reach up to n cube if the input given to us is n, or the length of the array is n. So in the worst case this can be the time complexity. Now if you run this code with this time complexity, obviously it will give us this TLE error. So to avoid this TLE error and to optimize our solution from O of n cube to O of n, we use Kadane's algorithm. So that's why we need Kadane's algorithm to optimize our solution of maximum sum subarray. So now we understood why do we need Kadane's algorithm. Now let us understand what is this algorithm and how does it work. So let us see the algorithm now. So we want to find the maximum sum subarray. Now in maximum sum subarray there are two fundamental things. If your sum is positive and the number is also positive, your sum will keep increasing. And the second point is, if your sum till now is negative and your number is also negative, your sum or your new sum will also decrease. Let's say for example your current sum is 3 and the element you are present at is, let's say, ARR of I is 4. So obviously if you add this 4 to 3, your sum will increase to 7. So this is what this first point is saying. And what the second point is saying? So let me erase this. If your sum till now is, let's say, -2 and your current element is, let's say, -3, so your new sum by adding this -3 to your current sum will become -5. So this is what this second point is saying. So if your sum is positive and the element which you are currently present at is also positive, so your sum will increase. And if your sum is currently negative and your element which you are currently present at is also negative, then your sum will decrease. So basically this is the fundamental for this particular algorithm. So on the basis of these 2 points we will design our algorithm. So let us see what this algorithm actually is. So in this question we don't want to do anything, we just need to take care of these two things which you have seen till now. So first of all, what we will do, we will keep on adding the current element's value to our sum. And what we will do, since we need to return the maximum possible sum, we will keep one maxi variable which will store the maximum sum till now. So in the first step, we will just add the current element to our sum. In the second step, we will check if this sum is greater than the current maximum sum that we have or not. So we will try to update our maximum sum. So maxi will be nothing but maximum of maxi comma this sum. So this will be the second step. Now what will be the third step? Now our third step will be based on the second point that we have seen. If our sum is negative and the element is also negative, so our sum will decrease. Now there is no point to take this decremental sum. Why? Because we have already seen if our sum is -2 and our current element is -3, so our sum will now become -5, which is lesser than both of these individual values. So it's better to take one of the individual values rather than the summation value, because its summation value is more lesser than their individual values. So whenever our sum becomes negative after adding the current element, that means if our sum is negative, so we just need to reset our sum to 0, because there is no point in taking that negative sum forward. It will not help us, because rather we would take that individual negative element rather than taking their sum. So this will ensure that we don't take their negative sum forward. We take either of the individual elements based on whatever magnitude or value they have. So this is how this algorithm will work. So this is the basic algorithm. First we will keep taking the sum of the current element, then we will check for the update of our maximum sum, and then we'll check if the current sum is negative, we will just update our sum to 0 again. So this is what the algorithm is. So let us dry run on this example test case to see how our algorithm is working. So let us see now. So first we will declare two variables. Sum will be initially 0. Maxi, since maxi will store the maximum sum, so initially we will initialize it with int min. So our maxi will currently be int min. Now we are iterating with the help of I pointer, let's say. So currently we are at this 0th index. So we'll add it to our sum. So our sum will become 1. In the next step we will update our maxi. So maxi is currently int min and our sum is 1. So 1 is greater than int min. So we'll update our maxi to 1. So this will get updated to 1. And our current sum is 1. Then we come across this 2. Now we'll add this 2 to our current sum. So our sum will become not 2, sorry, it will become 3. So our sum will become 3 now. Now again we will check it with maxi. Now in the previous step we didn't check about that condition because our sum was already positive. So we didn't go on to that step because it was obvious. If our sum is positive, this condition will not be holding true. So that's why we didn't check that. So currently our sum is 3 and our maximum sum till now is 1. So we'll update our maxi to 3. Then we'll again go on to the next element. So our sum will become 3 plus 3, that is 6. Now this 6 is again greater than our current maxi. So our maxi will get updated to 6. Now we come across this -2. So we'll add it to our sum. So our sum will become 4. Now here also our sum is not negative. This element is negative. So till now our sum is not negative. Only this element is negative. So again this condition will not be holding true. This condition will be only holding true if this current sum is negative, not the particular element is negative. So our current sum will become 4. Now we'll again check up with the maximum sum that we have till now. So our maximum sum is 6 and our current sum is 4. So no, our maximum sum will not get updated. So then we'll go on to the next element. So next element is 5. So we'll update our sum to 9. Now we have the current sum as 9 and maximum sum till now is 6. So we'll update our maximum sum to 9. And then we reach the end of the array. So we got our maximum possible sum. So our maximum possible sum is 9. And is it the correct answer? Yes, if you see it here, 9 should be the correct answer. So this is how we will calculate the maximum sum sub array of this particular array, and we have seen the algorithm. So this was the actually the algorithm, how does it work and all that, why do we need that algorithm that we have discussed. So let us try to implement in the code now. So let us see the code now. So first we will declare a variable n which will keep the size of the our integer array ARR. Then we will declare two variables, that is current sum, we will name it sum variable, it will be initialized to 0. Then we will have the maxi variable which will store the sum of the maximum which will store the maximum sum sub array. So initially we will initialize it with int min. Then we will iterate on the entire array. So yeah, so what was the first step? First step is just simply adding the current element to our sum. Now what was the second step? Second step was to update our maximum if possible. So maxi equal to maximum of maxi comma current sum. So yeah, and what was the third step? Third step was nothing but to check if our sum is negative. So if our sum is negative, we just will update our sum to 0 again. So this was the entire algorithm which we have discussed in the in the drawing explanation. So in the end we will just return the maximum sum sub array that we have for that particular array. So this is how this algorithm will work. So let us try to submit if this works fine or not. So yeah, our code got accepted. So hope you learned from this video. Thank you.